Today's project involves this thing. This is a 3D printed frame that is built to fit on the bottom of an Victron Orion DC to DC charger. It's designed to fit these little fans, 30 millimeter. You could fit up to 3 of them in there. And what you do is you hook it up to a thermostat, and when the Orion gets warm enough, it'll trip the circuit and start the fans and blow a bit of air through the bottom, hopefully cooling it off just a bit and making it a little more efficient. Initially, I bought these little fans. These are 3.3 volt on the product page and 5 volt on the label, thinking, no, this is what I need. And I experimented with them, running some power through them, and they just were so weak at that voltage. And it got me thinking, surely there are 12 volt versions of these fans, and sure enough, there are. So that's the 12 volt version. So in the end, I'll have these two fitted in here, connected to this thermostat. Here's a loose one. Came in a 3-pack. This is a little handy dandy gadget. Just to make sure my voltage is just right, I've got a small converter. And what you do is you put some power on it, and you adjust that little screw and have a multimeter hooked up to it, and just adjust it until the voltage is what you want. So this thing is set for 12 volt. This power supply right here is set for 13.2, which is about where lithium iron phosphate batteries tend to like to sit. So I'm going to hook this up to this, to this, to these. Got my handy dandy Wago connectors here. Those can go away. So I've got those set up with butt connectors. I'm going to mount the thermostat. The Orion's here, vertical. This will be vertical, this will be vertical. I'm going to mount this to the side. So I need to cut some cable. That'll run far enough over here and give me a little bit of slack. I gotta figure out where to mount this too. And then the cables I connect up to the power will be however long I need. Gotta think on this one. All right. Got these fans wired up to butt connectors, and then temporarily again using the Wagos into that. Let's do a test to make sure it works. Beautimous. Use a bit of cool water. Shuts down. Now I just got to puzzle out how to deal with getting rid of these in a more permanent way. No more Wagos, it's all just wired up direct, and it works just fine. Here we go. I don't like dealing with all these wires the way they are. So what I think I'm going to do is use these little tiny little ferrules. These are 22 gauge ferrules. If I snip the end off a little bit after it's crimped, it'll fit in there pretty nice. And I'll make it a little bit more cleaner, a little bit more clean. Easier to get everything in there, because I only have to get the wires into the ferrule and crimped once. If I have to take it out, move stuff around, then it's simpler than trying to stuff those wires up and twist wires together and twist the screws down. So these little thermostats came with these little packages. This is basically a case you assemble. These little pieces on the sides slot in, top and bottom, and you put them together. And one of the things that I was reading on Amazon are people going, yeah, but it covers the display. It covers the numerical display and you can't use it. What the hell? Why did they do that? Turns out this is just a backing material on the plastic that they had cut out. And you just peel it off with a piece of razor blade. It comes right off. So there you go. You assemble it, you attach the board to the bottom piece with these bigger screws. Put these little pieces together, and there's cutout for the terminals. Cutout for the buttons, you can still get at them. Cutout for the thermistor connection. It came with these little spacers. I don't know if that's going to be clear enough, but those are meant to go between the board and this piece. I ended up using just another set of nuts. They're the same thickness, plus a set of washers just to give it a little more space. So those contacts, all those little pins, aren't touching the plastic. So, next thing will be to mount all this stuff up. I've got a couple of little pieces of Velcro I cut. One to go on this, one to go on the electrical mounting board. And just stick it up there, it'll be fine. It's not going to go anywhere. I do still need to go get, where's the other one? A couple of decent fat screws to mount this part up with. Got the fans mounted up with some hardware. The stupid thing is these little 30mm fans came with screws and nuts. The 12-volt ones did not. And these things are a little bit thicker than these, so this stuff doesn't work. Went down to my friend's shop. He had some spare screws that are a little bit too big. I ended up using my broken piece just to drill out a hole and make sure it would fit. Drilled out 4 holes. Got these mounted up. I'm going to saw these off later. I got everything wired back up with the thermostat in the little case. I got these terminals on the ends of the little converter, so I can plug or unplug that up easy enough. And I'm going to do a little test just to make sure everything is working and I didn't screw anything up. Keep going. There we go. Beautimous. So I've got that dongle moved over a bit. You can see the old screw mount hole there. And then this little frame is in place. The designer added a couple of holes on the tabs on the side to mount it to the Orion, but it fits on pretty snug. I'm going to see if that works. If it doesn't, then I'll have to take the Orion out and do a proper fit. And that'll be a pain in the butt. And then here's the thermostat, and that's going to go right in that space. And the little converter I'm going to mount just above, right about there. Time to do a little testing. Everything's wired up. I've got power coming from my little benchtop supply, which is plugged in over there, going through in the inverter. But I will end up wiring up. I'll run a 16 gauge wire, snake it through the hole and to my fuse panel. But for now, we're just going to test by warming up that thermistor. Success. So I've got that wired up. Runs behind the board to this position. Now plug in this 5 amp fuse and that should give it power. And you should be able to tell just by looking at the display. And look at that. Next up is to secure the thermistor up above the heat vanes so that the heat rising trips it. Not a perfect install, but it'll do for now. Got the thermistor mounted up right there. Access kind of zip tied. Next task is to burn some battery, take it for a spin, watch the amperage over a set course, bring it back in, let it cool down, and then engage this thing and see if it makes a difference on the same course. It's been a busy week. I'm just getting around to testing this stuff out. I've got that fuse pulled out, so everything is off. No lights on the thermostat. And I'm gonna take it for a good drive, let that thing heat up, see what the amperage drop is as it heats up. Then tomorrow do the same drive with the fans enabled and see if it makes any difference. On both drives, I'm going to set the screen record on and monitor the amperage going in via the shunt. And that's about it. Can't really monitor the temperature on this thing. So we will see what happens. Let's go for a drive. So, because I just can't leave well enough alone, I'm not really happy with the thermostat solution. And what I think I'm going to do is I'm going to wire this thing up so the fans come on whenever the DC to DC charger is enabled, which means basically looping it into that switch on the dashboard. A switch just like this one. So I'm going to test using, instead of the thermostat, as a relay, an actual relay, an automotive relay. I'm going to wire this up between the power supply and the light as a test, and this switch, and make sure that switching this on turns the light on. And if that works, then I can just translate this into the van, hook it up to the cable that I've got running from the dashboard, the switch on the dashboard to the Orion, that enables or disables that as a whole. So whenever I flip that on, the fans come on. Right now I've just got this little light hooked up at 12.8 volt just to test, and that works great. So now I have to go puzzle out the wiring diagram. 2 of these wires go between the positive of the power supply and the light, and the other 2 go to the switch. Flip the switch, enable the relay, light comes on. Let's see if we can get that done. So I'm looking at this going, where's the actual labels for what wire is which? And turns out you just have to take this thing apart. And the numbers are hidden. They're very faint on there. You can't see them on this camera, I'm sure. But there's 30, 85, 86, 87. So now I know which wire is which based on how this connector goes on. I can get this thing wired up. I'm going to wire up the switch first. So after struggling with this for a bit, I finally just took all this stuff down to my friend's shop down the street, who knows this stuff much, much better than I do. And after about half an hour of him explaining how this should work to me, and me just not getting it, I'm trying to explain that I need the switch. Right now I've got the switch in the dashboard that just has a pair of cables going to the DC to DC charger, and all it does is close the circuit. There's no power to it. And everything I'm seeing tells me the relay to operate requires power. And I'm like, but I don't think I can run power through that connector on the DC to DC charger. I'm afraid I would fry something. That's an expensive unit. And we just kept going back and forth until I finally realized what he was telling me, which is I need to put the switch on the other side of the relay, on the side that has the power. And that's the white and the white and yellow. That enables the switch, but that closes this circuit. And you don't necessarily have to have power going through the circuit. I was thinking this circuit, the red and the black, I would put the power for the fans on. But no, it's the opposite. What I'm going to do is this switch will be wired up to the power to my DC 12 volt fuse panel with a little 5 amp plug, 5 amp fuse in it. That will go to the fans, which this is simulating, and it also goes to the relay. And then that closes the circuit, which gives me continuity here, and this will be connected to the Phoenix connector on the DC to DC. So right now, we've got the power on, switch, and that's the continuity off of my multimeter. And now that I know what I'm looking at, it's simple, but it took my brain half an hour to finally come around to just like turning everything 180 degrees, basically. Moving this from one side of the relay to the other side. That's basically all it was. So now that I know what's going on here, I can take this out there, install it, switch some wires around, and that should do it. So let's see what happens when I do that. I hope you can hear that. The fans are running. I'll hook through the relay. That's where the power's coming in, and that pair of cables, pair of wires going back, are basically switched through that switch up there. That is just dangling right now. I got a lot of cleanup to do. I'll have to put this back. I can turn this off. And now the fans are off. And also, the relay controls whether there's continuity in that connector. So I flip that switch while I'm driving, it'll turn the fans on and enable the charging. And I won't have to worry about temperatures or anything. I just let it go. Sweet. Sweet success. The one issue I've got with it right now, I believe, is the voltage. Before, when I had the thermostat set up, I was using this little converter, this little regulator, to step it down to 12.8. And in the process, you can see where those mounts snapped off. Weak. Fortunately, I've got another one of these. when I had the fans running just now, I think I could smell a little bit of little cooking because the voltage is too high. So I'm going to put one of those back in place. And what I can do is I can just put it in between these wires right here. Are coming in the back. This cable right here. I'll just basically take another one of these and I think I'll just mount it in the back. Right there. Hook this cable up to one end and run the other end back through and connect it up again. That should do the trick. I ended up doing 3 test drives to try this out. The first one with the fans not on, just to use as a baseline. The second one was with the thermostat in place, kicking the fans on when the heat got up to the point that it turned on. And the third test with the final config, which is the fans always on when the charger is enabled. I made screen recordings of all 3 drives, and you're going to see they're sped up at least 10 times just to make this go quick. This charger starts off strong, but as it warms up, the efficiency goes down and the amount of current it pushes goes down too. The whole purpose of going through all this trouble is to keep the amperage up as much as possible. And with the fans always on, that seems to be working a lot better than the previous 2 tests. You can see here on the third test, the amperage is still in the mid-20s, where the other 2 have dropped down into the high teens or the mid-teens. So I'd call this a success. It's a middling success. It's only going to help so much. But this is just how my brain works. I want to fiddle with things and see if I can make them better. I'll put links to all the various little gadgets I used in the video description.